So let's write the program for it. So in the front panel, I would be needing an XY graph. So this would be the first time that we'll be using XY graph because we want to plot the voltage and current values here. So this would be current instead of amplitude. So far we were just doing the waveform graphs, but this is the first time we are going to do the XY graphs. Okay. And then I want a button to turn it on, turn the power supply on. Okay, now going to our block diagram. So what we want to do is we want to have a for loop. We want to gradually increase the voltage across the at the power supply in the steps of 0.05 volts and do about 40 iterations. So that our supply voltage is gradually increasing from 0 to 2 volts. So the maximum you can go up to is 5 volts, but I'm just going till 2 volts. You can increase the number of iterations such that you can go up to 5 volts. It's up to you. So I'll choose a for loop first and have this wind it up to a constant. So I'll give it as 40. Okay, and then I am going to apply the sequence structure here. Because I want to first turn the power supply on, set it to a certain voltage, and then start collecting the values. So that's why I'm using a sequence structure. I want to use a flat one, so replaced with stacked sequence. Okay, and now I'm going to take this and multiply. I'm going to multiply the iteration number with 0.05. This is my step size. And now let me increase the size of this. So this is integer type. I'm going to delete this and add a floating point constant. Okay, and this I will give as an input to my power supply. So let's come to the power supply. So we will have to first initialize and configure it. For that, we go to the measurement input output. And then choose power supply and then say initialize. Again, we go to measurement input output, power supply enable. Measure. And then we have to configure it. Configure voltage output. And then go to read output. So it will tell the actual voltage that is being outputted. And then we are just supposed to close it. Okay. And device name. Analog Discovery 2. Connect this to this. And enable outputs. So if you want to turn on the power supply, you just have to connect this. And whenever we turn on the button, then the power supply is also turned on. It's a good practice always to turn it off and not let it remain on. Then we connect this here. The channel. So we have two power supplies, the positive and the negative. Positive 5 volts and the negative one. So we are going to use the positive power supply. So you have to write PS/1. Oh, sorry, PS plus 5 volts. Sorry, it has to be caps lock V. So please write it as it is. Otherwise, it won't identify the channel. So PS should be in small letters and there should be plus and then 5 volts and V should be in caps lock. Voltage level. Yeah, we are going to set the voltage level here. So let's take this output and connect it to the voltage level. And the current limit, just create constant. So by default, it's 0.1 and just let it be as it is. And then I want to connect this here. Okay. So we are trying to read the output of our actual output voltage of our power supply. So we are going to create an indicator for that. Okay, I think this is enough. Now we want to, so first we are done with the first part of the code, that is to initialize, configure the power supply and set the power supply voltage. Then we need to add another frame. Yeah, this is the next frame. So in the next frame, we have to read the voltage values. Okay. So for reading the voltage values, we are going to use the oscilloscope. So for the oscilloscope, I think now you are very much confident about it because we worked on it in the previous lab. So let's go to the measurement input output. So initialize. So we are going to just read the DC values. So you don't have to use the trigger function. We're going to configure this. Now we have to enter the channel number. So it's going to be MSO/1. Probe attenuation, create constant. For everything else, I think you just have to go on creating the constant. Enable channel, create constant, true. So when you click it, it turns into false. Then next, we are going to pass this instrument handle here. have to close this oscilloscope. And one more thing that I forgot to do is to, have an dialog box will displays errors. Okay, it wasn't this one. Simple error handler VI. I'm just going to copy paste here. Okay. So as you can see here, the output, we have analog waveforms and then we have digital waveforms. So we are just going to deal with the analog waveforms. And again, we are just going to extract the first array. So it is a cluster type and it has two arrays, the output here. So we just want the output from the channel 1. So for that, we go to array. No, sorry, waveform. Index waveform array. So we want to get the first array. Let's have this here. And this is my output. So I'm going to get a set of array, but I am going to use a function that calculates the basic RMS value. Basic DC RMS. So this will be our voltage value. Yeah, now we have to, there is no onboard ammeter. So we have to convert the voltage into current. So we are going to measure the current across the resistor by subtracting the measured voltage value across the diode that is being subtracted by from the supply voltage, and then you divide it by the resistance value. So the resistance I'm using is 100 ohms. So I have to, okay, let me just write it here so that it is clear for everyone. No. Okay, we have an error here. What does it say? Required input channel. Channel is not wired. Okay, we need to wire it to read voltage of channel plus 5 volts. Okay, I'm just going to connect it here. Okay, here I'm going to write down. So we are going to measure current I across the resistor equals to V supply. VS stands for V supply minus V across the diode VD over, you're going to divide the entire term by the resistance. Okay, so we have the VD here, and I'm going to use the subtraction term here. And the supply voltage is here, the actual voltage. So I need to pass it on to the next data frame. For that, I have to right click and say add sequence local, and then wire this up. Okay, now it's being passed on to the next frame. So I'm going to utilize this value here, connect it here. This is my supply voltage minus the VD, and then I need to divide this value by 100. It's better for me to write here resistance. And then this is the output is our current value. So this is my Y, and this is my X. So we have the voltage across the diode, and then this is the current because in the resistor, and since they are resistor and the diode is in series, we have the same current flowing. So in future, if you plan to do some project with AD2, you cannot measure the current directly. So always you have to use a series resistance, and then you can calculate the current from there. You have to do it indirectly. So now we have the current and the voltage. We are ready to plot them. So this will be my Y and this will be my X values. And this is my XY graph. And as you know, for the XY graph, we need to use the bundle function. We have a set of, we need an array of, we'll be having an array of current values and the voltage values. So we use the bundle function because the input to it is a cluster. So we have to use a bundle function. And these are like floating point arrays. So let us, this is X, right? Okay. And then make sure it is in auto index tunnel mode, because we want to create an array by storing, so in each element of the array corresponds to the voltage and current value. Then we connect this here. Okay. Make sure this is like X and this is Y axis. If you do it, like if you interchange, then you get like an inverted graph. Okay, that's all. Just turn this on first. So you see, just clear the data from here. Okay, let's turn this on first and run this. As you can see, the voltage value is gradually increasing, and so is the voltage across our diode. And here you go. We have the voltage current characteristics. So that's so simple and easy. Yeah. So to give you a summary again, so first we plan to increase the voltage gradually in the steps of 0.05 volts. For that purpose, we have, and we want to have like 40 iterations. So we have built a for loop, and then we are using a sequence structure because we want first the voltage supply to be turned on, and then we read the values at the diode. So for that reason, we have like increased we have used a sequence structure. Then we increase the voltage and supply the voltage to the uh, power supply. And outside the loop, we always initialize and enable the power supply, and configuration will be inside the loop. And then we are reading the voltage, the actual voltage level. Now, the second sequence is all about reading the voltage across the diode. So we have initialized and we have configured, and we don't have to use trigger because we are just dealing with the DC values. And then we have, we run the mixed signal oscilloscope and then read values. And then since we are using only one channel, we are going to extract the array that corresponds to our channel 1, and then we are going to have the basic DC RMS values of that array. And we also have to convert we have to indirectly measure the current by taking the measured voltage value and subtracting it from the supply voltage, and then divide it with the resistor, and then we plot. So in the end, we also like close this VI sub VIs, and we use this error dialog VI. And it's always a good practice to use a shift register for the error. So we are again going to add another shift register here. I'm gonna delete this. Okay, so yeah, so we are done. Thanks for listening this lecture, and I hope you had fun preparing this code.